Ever stared into the night sky and wondered if we're alone in the universe? This question has been on the minds of humanity for centuries. As we begin this exploration, we turn to the insights of physicist Brian Cox, a man whose career has been dedicated to unraveling the mysteries of the cosmos. Our universe is vast, almost unimaginably so. With an estimated 2 trillion galaxies, each containing billions of stars, the sheer scale of existence is astonishing. Within this cosmic expanse, the potential for life beyond our own blue planet seems not just plausible but inevitable. Yet the question remains, where are they? This is the extraterrestrial enigma, the paradox of a universe so vast and yet seemingly so silent. To grapple with this question, we turn to an equation that has guided scientists for decades, the Drake equation. Named after astronomer Frank Drake, this mathematical formula attempts to estimate the number of advanced civilizations in our own Milky Way galaxy. The Drake equation accounts for factors such as the rate of star formation, the fraction of those stars with planetary systems, the number of planets that could potentially support life, and the lifespan of such civilizations. Yet, despite its comprehensive nature, the equation is ultimately speculative. It's a tool, a starting point for discussion, rather than a definitive answer. But let's consider for a moment that the estimates are correct, and there are indeed other civilizations out there in the cosmos. This brings us back to our original question, but with a twist. If there are civilizations advanced enough to communicate across the vast distances of space, why haven't we heard from them? This is the paradox at the heart of our search for extraterrestrial life. A universe so vast, yet so silent. A cosmos teeming with potential, yet seemingly devoid of companionship. It's a question that stirs us, challenges us, and drives us to delve deeper into the mysteries of the universe. But if the universe teems with life, why haven't we found any aliens yet? Enter the Fermi Paradox. It's the contradiction between the high probability of extraterrestrial life and the lack of contact with such civilizations. The Fermi Paradox is named after physicist Enrico Fermi, who famously asked during a casual conversation in the summer of 1950, "Where is everybody?" His question was simple, yet profound. It encapsulated the paradox that arises from the contradiction between the high probability of extraterrestrial life and the glaring absence of evidence or contact with such civilizations. Fermi's question was based on a few logical assumptions. The first being that there are a potentially large number of technologically advanced civilizations in our galaxy. The second, given the age of the universe, it would have been more than enough time for these civilizations to make their presence known to us. So, why the cosmic silence? This is where we delve into the two main solutions to the Fermi Paradox. The first solution posits that the existence of life, specifically intelligent life, is extremely rare or unique to Earth. Perhaps the conditions required for life to evolve are so specific and intricate that they have only occurred on our planet. The second solution is a bit more unsettling. It suggests that intelligent life has a tendency to destroy itself. In other words, civilizations might emerge and develop advanced technology, but then self-destruct due to factors such as war, environmental exploitation, or other existential risks, before they have a chance to communicate with other civilizations. These theories aren't just conjecture, they're derived from our own observations and experiences. We know how rare and specific the conditions for life on Earth are. We also see how our own technological advancements have brought us to the brink of self-destruction more than once. The Fermi Paradox forces us to confront the reality that we might be alone in the universe, or that civilizations are doomed to self-destruction. Either way, the paradox serves as a humbling reminder of our place in the cosmos. Both solutions present a rather bleak outlook, don't they? What if we're living in a cosmic zoo, observed by aliens but left undisturbed? This provocative question introduces us to the zoo hypothesis. This concept surmises that advanced extraterrestrial life may well be aware of humanity, but have consciously chosen not to interfere or make contact. It's a fascinating theory, sparking intriguing questions about our place in the universe. Are we a protected species, watched over by cosmic park rangers? Or are we an experiment, left to evolve naturally, with our every action under scrutiny? The zoo hypothesis raises philosophical and ethical questions too. If advanced life forms are indeed observing us, what does that say about their respect for our autonomy, our free will? And what might it mean for our future if they were to break their silence? It's a humbling thought, isn't it? But there's more. Imagine a civilization so advanced that it has transcended our physical reality. This is the intriguing premise of the transcension hypothesis, a theory that might just explain why we haven't stumbled across any extraterrestrial neighbors yet. The transcension hypothesis suggests that civilizations reaching a certain level of technological sophistication will inevitably leave our universe. It's a concept that takes us into the realm of the truly extraordinary, a realm where advanced civilizations evolve beyond our physical constraints and into a domain we can barely even comprehend. Now you might be wondering, how does a civilization just up and leave the universe? Well, to grasp this, we need to delve into the mind-boggling concepts of post-biological evolution and the technological singularity. Post-biological evolution refers to the idea that biological beings, like us humans, could eventually be replaced by artificial intelligence and machine life. We're talking about a future where we might shed our biological bodies and upload our consciousness to machines. In this scenario, we are no longer limited by our biological lifespan, physical abilities, or even the need to inhabit a physical space. This leads us to the concept of the technological singularity. It's a hypothetical point in the future when technological growth becomes uncontrollable and irreversible, resulting in unforeseeable changes to human civilization. The singularity could be a point where a civilization has developed technologies so advanced, they have the ability to manipulate space and time itself, thus enabling them to leave our known universe. So, according to the transcension hypothesis, advanced civilizations don't just disappear, they transcend. They move on to a domain beyond our comprehension, beyond our universe. They leave no trace, no evidence of their existence in our universe, which could explain why we haven't found any signs of intelligent extraterrestrial life yet. It's like something out of a science fiction story, but who knows? Perhaps one day we too might take that leap into the unknown, transcending our physical reality and embarking on a journey beyond our universe. Perhaps the answer lies in the Great Filter, a theoretical barrier that prevents civilizations from colonizing the galaxy. The Great Filter theory, proposed by economist Robin Hanson, is an answer to the Fermi Paradox, the apparent contradiction between the high probability of extraterrestrial life and the lack of evidence or contact with such civilizations. It suggests that there's a barrier or a filter in the evolutionary process that is difficult for life to cross. The filter represents a stage in evolution so challenging, so dangerous, that it eliminates almost all civilizations that encounter it. This filter could be anything: a natural disaster, a self-inflicted catastrophe, a technological hurdle too high to leap over. The idea is that this filter is so challenging that it wipes out almost all civilizations that reach it, preventing them from exploring or colonizing the galaxy. Now, if the Great Filter theory holds true, it leaves us with two possibilities. The first is that we're one of the few, if not the only, civilization that has passed the filter. This means that the steps leading to our current level of intelligence and technological advancement are incredibly rare in the universe. The filter lies in our past, and we've already crossed it. This could be the emergence of multicellular life, or perhaps the leap from prokaryotic to eukaryotic cells. The second possibility is more ominous. It suggests that the filter lies in our future. We've yet to face this test, and when we do, it may be our downfall. Perhaps it's the creation of artificial intelligence, or the ability to manipulate genetic codes, or even the mastery of a new form of energy. It's a daunting thought, isn't it? The Great Filter theory leaves us with an unsettling question. What if the silence of the universe is the sound of countless civilizations failing to pass the filter? It's a chilling thought, one that reminds us of our fragility and the high stakes of our technological advancement. The search for extraterrestrial life raises more questions than answers. As we wrap up our journey through the cosmos, let's take a moment to reflect on the theories we've discussed today. The Fermi Paradox, the mystery that with so many stars hosting planets, why haven't we detected signs of life? The zoo hypothesis, suggesting that we are being observed by alien civilizations, much like animals in a zoo. The transcension hypothesis, that civilizations may reach a point of technological singularity, becoming unobservable to us. And the Great Filter, the notion that there might be an insurmountable barrier preventing the rise of advanced civilizations. Each of these theories offers a unique perspective in our ongoing search for extraterrestrial life, a quest that not only seeks answers but also strives to understand our place in the universe. As we continue to gaze at the stars and wonder, the question remains, are we alone in the universe?